Hello everyone. Today I'll be attempting to give an overview of a small piece of code I've written to predict the Instagram post analytics or engagement that you will get or that you might get if you do a post at a certain time with a certain color palette, etc. And in this code I've used machine learning using sklearn with decision tree. You might be able to get better results using some other models, and if so, uh, feel free to commit on the GitHub code over here. You can just fork and push your updates, and um, nice improvements are always great. So I'll also explain you the working of this code as well as how to get the data from Instagram. So if you visit instagram.com/accounts and slash privacy and security, or you click on your profile icon on the top right here and click on settings, you'll come into this page. Okay, so it's settings and alright, so I think you'll need to enter this URL directly. So just come hop on to this URL, click on request download, and you'll be brought into this screen. You can just give them your email address, and in a couple of minutes you'll get your entire data data links shared over your email. You for this purposes, you will need to choose the data as JSON, and you can click next, and you can enter the password, and then you shall get the zip which can be downloaded. So for my case, I did download and extract the zip. So the second step will be creating a folder called assets on the root directory of the code. So that's here, and creating another folder called past Instagram insights. So this is the code over sorry, this is the data set that Instagram provided for me over here. And the main file for today that we'll be looking onto is the posts.json. So this is all the data that we have. My account has about 300 to 400 posts, I believe. So um, your model can be highly performative if you have more posts, since you'll have more data um, to go through, and the model will be highly more accurate than if you have just a few posts. So make sure that the post.json that you have contains more data. The more the merrier. Coming on to the code, these are the simple instructions that I've written, whatever I narrated right now. So you can just have a look at it and follow them if you wish. So starting with the first cell of this Jupyter notebook, I'll try and install pandas here. Since we'll be using data frames from Panda to be able to construct tables and manipulate those tables and then train them eventually. So we'll be importing pandas, and I've just set the parent folder path as the folder that I showed right now. So this will be the path, and the initial file name will be posts. So I'll show in upcoming cells what this file name does. I'll just run this and make sure that we have everything installed and initialized. Now coming on to the second cell. So as we saw here, the data set we have is in form of JSON. So we'll need to convert this JSON schema into tabular forms so that we can go through the table effectively and train our model. So the second cell does the exact same thing. We have a function called convert JSON to CSV, which takes in the JSON file and which converts the file into a CSV, which is the parent folder and the posts.csv. So that's where it will get stored. I'll just run this function so it is defined. This is where we call the function. We supply the parent folder path, which is our assets directory and this folder, and then we have the file name, which is posts, um, which is defined over there. So it will be stored as a CSV file over there. So once we go through this function, we should be able to see this posts.csv. So I'll just open it and make sure that it is all right. It's trying to open, finish. Okay, we don't need this for now. So we can see that we have all the columns. So we have post media, we have creation timestamp and post likes. So currently I'll just be using these two as a feature set to be able to try and predict how many likes and reactions will my post get. And actually I'm also using another feature called hashtags, which are taken from the title, which I'll be going through after this. So here we run the function and we generate the CSV file. We also load the CSV file over here using the read CSV function from Pandas, and I will run this as well. So we read the CSV file, we set the CSV file to data frame, and we can see I have about 540 posts, and 4 are the number of features that will be going to use. We have something called title, we have the post underscore media, and this is just the path of the images or the media. So it can be either images or videos that we have, and that is in relation to this folder. So for example, this thing says media slash posts slash the folder name, so it'll be media posts, and here we have all the posts that we have. Coming back to the code, we also have the creation timestamp. So this will be really important to predict and classify based on the time and the day that we had posted historically, what posts can perform better and which will not. So we should be able to get the time frame where when we get the most amount of engagement, and we also have the post likes. So this is the just a target value that we'll be using. The higher the post likes, the better the post performed. So we now know that we have the we are able to load the CSV properly. One thing here, I have only loaded the first 50 the first 50 cells from the 500 data sets, sorry, the 500 rows that we have. And during production you may comment this out like so. Currently I'm only using the top 51 because there are a few computationally expensive functions that we have written down below, which I'll be referring later in this video, and which might take a lot of time, especially while I'm recording the video. I might not want that. So coming on to encoding the post likes. So since we are using the decision tree algorithm, which is a classification based algorithm, we will be predicting or at least giving the results in form of if the we will be giving the results in form of classifications. So meaning if we can classify the results in form of if the post performed not really well, maybe it performed regular or medium, and it performed really good. So I'm just taking the values from the post likes, and I'm just taking the 25th percentile, 50 percentile, and 75th percentile from the values. And so that's how I'm giving the low, medium, and high. And I'm just encoding it in values. So low will be 0, medium will be 1, and high will be 2. So let me run this as well. So we have the entire likes encoded. All right, so I think 0. All right, so the first row is the index and the second one is the low, medium, high. So the next step will be fetching hashtags from the title. So going back to the CSV, we can see the title. Let me just grab this, open Notepad and try to see. All right, so I don't think I am able to get the entire variable. Let me try and open the table. Let me check. Okay, so the data frames here. Let me open in another window. Let me expand the title. Okay, I can see a few hashtags over here. So generally what we like to do is place hashtags in the title to help us and let Instagram know about the category of the post and help with the engagement and being able to bring the algorithm being able to recommend the posts depending upon what hashtags we use. So in this tab we just go through each and every title, we grab all the hashtags that we have, and we just create a dictionary and we add all the hashtags on this dictionary. The next step is after adding all the hashtags in the dictionary, we sort the dictionary in such a way that the hashtags that have received more number of likes have more priority than the hashtags that don't. And so currently I will take the first 5 hashtags with the highest priority. So for example, for us, these hashtags will be post likes, app design, daily UI. So these are the most performative hashtags that we have, and I'm just creating another cell for each and every hashtag, and every hashtag will have either 1 or 0, 1 denoting if this particular hashtag is used in this post, 0 denoting it's not. So, and it's a binary value, so it lets the decision tree calculate effectively which hashtags work and which don't. It is also possible to play around with this number and see what gives us the best results. But for now I'm just keeping this at 5. Going on to the next step, all we'll do is separate all the date fields. So currently we have just a single creation timestamp. Now our algorithm might not be able to understand quite what this date means. So it might be better in order for the algorithm to predict in a better way, we can just segregate these hashtags, the timestamps into maybe the number of days. So it might be Monday, Tuesday, Wednesday, and also the time. Time can also be converted into just an hour and minute. So that's exactly what I've done over here. Let me also print out the data frame. Okay, I think this will need to complete. Let me just interrupt, run this. Alright, we should have the post time. So I've just converted the time into hours and minutes. So 12.5 will be just 12 hours and 30 minutes. So that's how I've converted the time. So after converting the time, I then go into the image itself. So there might be many different ways to classify different images. We might be able to do some complex object detections to know what kind of objects are there in the images, what kind of text is present in the images, to be able to get more detailed information about a single post. But for this algorithm, I've restricted that feature set into just grabbing whatever the dominant color from the images. So for example, and this is what I have also noticed as well, the posts which have blue background color have generally performed good for us, and they get about 2 to 3,000 views. as opposed to images which do not have such popping colors. So that might be a relevant information we can add. So for that I am just using the combination of library color thief and web colors. What color thief does is it goes through the image and grabs all the hex values of all the different colors the image has, and it can also give you the dominant color, which I am doing right now. So if you remember, we had this part to the image, and that's how we are grabbing each and every image and then getting the dominant color from the image. We are using web colors in order to give in order to convert the hex frame, the hex value of the image's color into the name. So for example, if blue has certain hex code, we just convert that hex code into blue, and this will help us in order to segregate different similar type of hex values into a single color. So for example, we have a color, let's say pink, and a color light pink. Now that both of those might we might be able to get them into a single category, and that's just pink. So this is what I'm doing here. I go through each and every cell, get the image's color, and update the color. So and this step is really expensive computationally. So for me, about 500 posts take 10 plus minutes, and that is the reason I only use the first 50 for the demo. Another thing to point out here is if it's a video, I just in color string I just say video, and I don't try to get the color of every frame or even the first frame, because in video that might not be relevant. It is obviously possible to get and query different audios that we use. For example, in Instagram currently, reels have a lot of influence, or should I say audio has a lot of influence over what reels Instagram shows you. So that can be an additional step. If you guys want to see that, just comment down below, like the video. I'll be able to do that in the next update. So currently I've just converted the first 50 cells into whatever color it has and the video. So for example, this is what has gotten back from the loop. So it's black, these three are videos, and then it's dark slate gray, and then it's light blue. So that's how we are getting the all the 50 rows. Now I'll just drop the all the unwanted values, so which will be title, the path of the image, even creation's timestamp currently is not valuable since we have already extracted out the individual time. So I'll just clean the data set and see how it looks. So I think these should be the most important features that we need right now. So after this, what I usually do is I just save the data set named whatever the value was, so posts underscore clean. So since extracting colors out of image was so computationally expensive, I'll just straight away save the clean CSV, so that if we want to run the algorithm again and predict some other kind of posts, we can directly do that using the CSV, and we don't need to go through all the process again. Not really sure why this isn't opening. I think we can. Okay, so it's the same CSV as this, so I don't think we need to print this. Okay, and this is just loading the saved CSV. So if we don't want to follow any of the steps, or we don't need to, if we don't want to redo all the steps from above, and we have this clean CSV saved, we can just start our project from here. So it again loads the same CSV. Now we can try and visualize all the data. I've used the SweetV's library over here. So you can perform all kind of EDAs if you like. So this will be different in relation to different data that you have. Coming into encoding the data, so currently we have the colors as named string values, which is not really trainable. So we'll just convert this into integer values, so our algorithm will be able to perform calculations on that. And same thing goes to post likes as well. So coming on to encoding data, I'm just using sklearn for it. So using the pre-processing module, I just convert the dominant colors as well as post likes into numerical values. So now we have all the data encoded, and we can just supply this straight to the algorithm in order to test and train. So I'm just, from this cell we will be trying and training the data, sorry, training the model. So we split the data into x and y, x and y variables. X will be just the feature name, sorry, the feature value, and y will be the target value, which is the post like which we want to predict. I'm giving the split 30-70 percentage of split, and I'm also creating another validation set. So this is the amount of data that we have, fairly low but works for this demo. Here I'll just go ahead and train the decision tree. So I'll just import the decision tree classifier from sklearn tree, and I'll just fit the test all the features as well as the target value, and that's how it's done. I'll validate the decision tree using the validation. The score is 0.5. Now this score is not really great, it's just a 50% accurate. Having given it about 500 or so posts, it becomes about 80% of accurate. But I'm really sure if we use something like random forest, we would get way more higher accuracy. And testing again the decision tree, it comes into 0.5, and this last cells will be actually trying to predict a post. So for example, if we include all the hashtags that we have, UI, trends, app design, all the great hashtags, if we have the post time as 8 a.m. and we have post dominant colors as 4, whatever that is, we can make sure by having a look into the CSV. So let me just try and see for the ID 38. So it is light sea green, that's the color that we are going for. Maybe we can try some other color. Let's say midnight blue is okay. Midnight blue is 19, and for 19 we have the integer encoded as 7. So we can change this as well, but let's see what it comes up with this. And getting the results, it says it will get medium likes. For us it means about average, so 50th percentile mark. I can maybe try and remove a hashtag and see how that performs. I can try and let me make it something like 14, and colors can be 7. Let me run the prediction. Okay, so the same thing, it'll receive medium likes. We can obviously try more permutations and combinations, seeing what received high amount of likes, and use that. So yeah, that's it. This can certainly be improved, including more definitions for image as well as video. So that might come in the later videos in the series. Thanks for watching.